As part of our statistics unit, one thing that we're going to look at is some different ways that you can organize sets of data. Today we're going to look at one of those ways, and that is a line plot. Line plots specifically are used to organize data on a number line. Now there are some tips for making a line plot before we actually try setting up a line plot to see what it looks like. So some tips. It helps to find the smallest and the largest data in your data set when you're setting up the scale. The reason for that is because we're putting the data on a number line. We want to make sure everything's going to fit. So we need to make sure that the number line goes down to the smallest number and up to the largest number so that we're not chopping off anything when we go to graph our data. The second thing, which is a reminder, will come into play in just a minute. When we plot data on a number line in a line plot, we use X's, or sometimes people use dots to mark the data. The important thing is that your X's or your dots, if you're going to use dots, all need to be the same size. So a good way to make sure they're the same size is they should, if you have multiple X's or multiple dots on the graph, they should line up in rows. For some reason, that just moved all of our numbers, all of our data, so we will put them back. So make sure everything's the same size. Goodness. And make sure your X's or your dots line up in rows. So that's a good way to see if your data is going to work. So we are going to actually look at an example of a line plot. So the best way to show you how to make a line plot is to actually make a line plot. So this is some data. It's snowfall data that was collected at a resort in different days over a 15-day span of time. So we said that our tips, we want to find the smallest and the largest number. So if we kind of scan through our data, we can see the smallest number is 1. And that shows up a few different times, but it is the smallest number. And our largest number is 12. So we would want to make sure our number line runs at least down to 1 and at least up to 12. It's a good idea to kind of go a little bit past those numbers so that you're not hanging right on the edge of the number line. So even though our smallest number is 1, I'm actually going to start at 0 just so that 1's not right on the edge of the number line. So I'm going to number it off. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to go a little bit past it. So our number line is actually a little longer than we need, but that's okay. One thing that's important with a line plot, and we didn't put it in our tips, but it's something that you need to be aware of. Sometimes when people make number lines for other reasons in math, they'll skip count. So they'll count by 2s or 5s or 10s on their number line. When you're making a line plot, unfortunately, you cannot skip count. You have to count by 1s. The reason for that is if you skip count, you risk skipping over some of the values in your data set, which leaves you with no place to graph them. So the only way to make sure that you have a place to graph every possible number is to actually put all of those numbers on the number line, or in other words, count by 1s. So we set up our scale. The other thing is we should always give our graph a title. And a lot of times with a line plot, people actually like to title it below the graph. So we'll call this snowfall data. You don't have to title it below. You could, if you really wanted to, put the title up here as well. But on a line plot, you'll see it both ways. So the next thing we're going to do is we are going to go through and just start marking our data. So our first piece of data is a 2. So I'm going to mark that with an X on the number line. And it's okay to kind of write over the top of the lines that are marking things off. So that would be my first one. My next one is a 10. So I want to put it and make it about the same size, but at 10. So if you look, those are kind of lining up straight across. They're not way bigger or way smaller than each other. And then I would keep going. I've got a 1. And again, notice that I'm trying to make everything the same size. I've got a 5. Now, now have another 2. I already have a 2 marked once on here. So if the number shows up more than once, what you do is you just start stacking up those X's or those dots. So since I have another 2, I'm just going to put another X right above the first one. And then I'm going to keep going and go ahead and get the rest of the data marked on there. And again, when I have places where I have repeat data, I just stack those X's up on top of each other. And there is my last piece of data. So again, something to point out about making things the same size. If you look, so I could line these X's up in rows. So there's all the ones that have one piece of data. Here's all the ones, the second piece of data. So you can kind of see how everything's lined up nice and neat and tidy. The reason why you want to do that is because people look at the heights of kind of how tall the X's are to see where most of the data is. So like on this graph, you could see there were more days where we got 2 inches of snow than anything else because that's the tallest stack of X's. Where it gets misleading is if you don't make things the same size. So I'm going to really exaggerate this, but let's say I did something like this. So you can see those aren't the same size. Some are bigger and some are smaller. This has 2 pieces of data and this has 3 pieces of data. But somebody glancing at the graph and not paying attention might think that they're the same because they're the same height. So that's why it's really important to keep your X's the same size so that you don't accidentally trick people with your graph. So that is what a line plot looks like. Now that we've made our line plot, there are some things that we can do to actually look at the data on the graph. And that's going to involve talking about a little bit of vocabulary that we're going to talk about right now. So there's some things that are easy to see on a line plot. One thing that's easy to see on a line plot, or easy to kind of calculate once the data is all sorted out, is the range or the spread of the data. So the range or the spread of the data is the difference between the largest and the smallest numbers. The nice thing about a line plot is that when you're putting the data in a line plot, the numbers might not be in order. So if you look at our original data set, the numbers were not in order, but once they're on the line plot, now they're all sorted out in order. So I can see that, okay, the largest number was a 12 and the smallest number was a 1. That's really easy to see on the line plot. So I would find the difference between those. So to get the range of the data, I would do 12 minus 1 or 11. So this data has a range or a spread of 11. So that's one thing that's easy to do once things are organized in a line plot. Line plots also show us some other things that help us to analyze or to look at patterns in the data. So a line plot makes it really easy to see things called clusters. So a cluster is a group of data that is close together with no breaks. So there is a cluster in this data, and that cluster is all of this data in here. So if you look, the data goes, I have data in the 1s, the 2s, the 3s, the 4s, the 5s, and the 6s. So all of those numbers have data with no breaks. So no numbers in there where I don't have at least one piece of data. So that's what we would call a cluster. So we could say there's a cluster in the snowfall data between 1, which is the beginning of the cluster, and 6, which is the end of the cluster. We could also talk about what's called gaps in the data. So gaps in the data are kind of the opposite of clusters. So gaps are spaces in the data, and they're usually the spaces between clusters or single numbers if there's not a cluster. So I see a couple places where we have gaps in our data. So there is a gap in the data right here, and then there's another gap in the data right there. So there's actually two different gaps or two different breaks in the data. So we could say there's a gap in the snowfall data between 6 and 10. So there's no numbers, no other data between there. And then we could also say there's another gap again between 10 and 12. So this data actually has two gaps, so we could list them both. Now, the last thing that you could see really easily on a line plot is what we call outliers. Outliers are numbers that are much larger, excuse me, or smaller than the rest of the data. So on a line plot, an outlier is going to look like a piece of data that's really far away from, or noticeably far away from, where the rest of the data is. So we could argue, especially since we've got that big old yellow cluster where almost all the data is, we could argue that 10 and 12 are outliers because they're noticeably far removed from the rest of the data. So we have a couple of possible outliers at 10 and 12. So maybe there were a couple of really big snowstorms that came through in those 15 days that dropped 10 inches and 12 inches of snow, and the rest of the days it was snowing a little more lightly. So those are the different things that are easy to see in a line plot. So a line plot makes it easy to find the range. It's easy to see clusters, gaps, and outliers. And also, we have an example of what a completed line plot looks like. At this point, you should have your notes outline filled in. So you should have your completed line plot, and you should have all of your vocabulary and calculations filled in. Assuming that your notes look like what you see on your screen, then you can go ahead and move on and try the U-Try problem.